Hello again, and this is my third series of video lecture. Today I will discuss agent to multi-agent system. So what is an agent? If you take an analogy in IoT, let me take a pen. So let's suppose you are interested in room temperature. This is for example, room, and there is a temperature sensor. That sensor is connected with Arduino board. This is the microcontroller MC, and the Arduino board has some sort of transmitter antenna or wired so that it can send data. So this is an agent. We have designed it for some specific purpose, and we in real environment we have more than one agent. And that is called multi-agent system. So let's discuss in detail. Okay, so the definition is that an agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through effectors. So agent is working in some environment and it's sensing something, and sometimes when it wants to act upon against the sensor values, they use effectors. According to this definition, an agent is any entity, physical or virtual, that senses its environment and acting over it. Physical entities that could be considered as agents are, in the case of power system, you can see the controller, any controller that can control power systems, or component of the power system, part of the power system, or the entire power system. And virtual entity that can be considered as an agent is a piece of software that receives inputs from an environment and produce output that initiate acting over it. And often physical and virtual, an agent is a combination of physical and virtual. A more precise definition of the agent: autonomous agents are computational systems that inhabit some complex dynamic environment, sense and act autonomously in this environment, and by doing so realize a set of goals or tasks for which they are designed. So it means the agents are autonomous and they are working in some dynamic environment, the environment where things are changes with passage of time. So those agents sense those changes, and those agents must have some goals for which they have designed. So the key extension in this definition with respect to first one are words computational, autonomy and goals. Word computational makes difference in agent that we are interested in engineering: computational agent from biological agent, human, animals, bacteria, etc. Autonomy means the computational agents operate without the direct intervention of some other entities and have some kind of control over their actions. Assigning the goals to the agent means that acting upon environment should be done in order to achieve some specified objective, and that the agent expose a sort of rational behavior in the environment. And behavior here means the action that is performed after receiving sensory inputs. A general diagram of a single agent is given here. So this is the environment and this is our agent. So the agent is sensing the variation in the environment through sensors and then acting upon the environment via effectors. So every agent has those things: goals, actions, domain knowledge. So in addition to the sensory inputs, actions and goals, an agent may include domain knowledge, the knowledge about particular environment or problem to be solved. This knowledge can be algorithmic, artificial intelligence based techniques, rule based or fuzzy neural networks, machine learning, or heuristic knowledge, common knowledge. In the case of AI, an agent is often termed as intelligent one. The notion of environment that an agent inhabits include physical system, operating system, the internet, perhaps combination of some of these. Physical entities and virtual, as I told you already, combines to constitute an agent. So agents can be of two types: reactive and deliberative agents. If an agent simply responds, so whenever the change comes, it just responds. This is called reactive agents. Reactive agents usually do not maintain internal states. A simple example of internal state is keeping a set of previous sensory inputs of the agents and do not predict the effect of the actions. On the other hand, if an agent maintains internal states, previous history of the actions or the data, and then based on the new input, when the new input comes in based on the previous input, that agent will do some sort of reasoning or thinking and then will behave in response. So that sort of agent is called deliberative agent. These are reactive agents and this is deliberative agents. Everything is simple, everything is same, except that it has previous states, previous data, instant data, and then evolution. Based on the previous data, it evolve and then do some predictions, and then it will react to the environment. This one, independent one. Okay, so let's suppose this is an agent and this is another agent and they're working in an environment. So for this agent, this entity along with others, everything is the part of the environment. So it might getting some input and produce some output, and that output might be the input of this one as well. So in that case we are saying that a cooperation emerged without any intention. So let's move on. The term deliberative in previous figure refers to the idea that agents jointly plan their actions so as to cooperate with each other. The cooperation within a multi-agent system can be realized in three ways: by explicit design. So basically we are discussing that in which scenario when the agents are cooperating. So the one is that by explicit design, we designed it for the purpose so that they can communicate. By adaptation, the individual agents learn to cooperate. With the passage of time, they learn to cooperate. And by evolution, individual agents cooperation evolves through some kind of evolutionary process, and they start cooperating with each other. And what are the advantages of multi-agent system? The main advantage of multi-agent systems are robustness and scalability. Robustness refers to the ability that if control and responsibilities are sufficiently shared among agents within mass, the system can tolerate failures of one or more agents. So if one or more agents are failed, the system will still will be in functioning mode. Scalability of mass originates from its modularity. It should be easier to add new agents or remove previous one, or add new capabilities to monolithic system. Independent discrete mass. This type of multi-agent system is encountered in the environment that permit decoupling or decomposition. As an example of this type of mass, we use two agents controlling synchronous generator in power system. Like in this system, you can see this is independent discrete mass. So they have no cooperation with each other, and they are not independent to each other. So for an analogy, they say that we have an agent of AVR, automatic voltage regulator, and the speed governor. So the speed governor doesn't have to do anything with AVR, and AVR doesn't have to do anything with speed governor. So these are two independent discrete. Yeah. KIF, knowledge interchange format for content. KQML, knowledge query and manipulation language for message format. So these are the protocols the heterogeneous communication multi-agent system use. COOL, coordination language for coordination. When agents communicate, they decide to cooperate on a given task or for a given amount of time. In doing so, they make commitments to each other. Committing to another agent involves agreeing to pursue a given goal, possible in a given manner, regardless of how much it serves individual agents' own interests. So you see, if they want to communicate, the heterogeneous, I'm talking about heterogeneous multi-agent system, if they want to communicate, they have to set some protocols, and they have to set that when to communicate, and they have to set some commitments that when they are working together, so some task will be assigned that you have to do this task, and you are responsible for this task for that amount of time. So these are commitments. So these commitments are assigned to them, and they will then work together while doing cooperation and communication. So there are in general three types of commitments. Internal commitments. So internal commitments, every agent has internal commitments. So what is this? An agent binds to itself to do something. And social commitments, an agent commits to another agent. Social agent is often used. And collective commitments, an agent agrees to fill a certain role in a multi-agent system that is termed as team agent. Okay guys, this was my third video lecture regarding multi-agent system, and see you soon with my fourth lecture. Up to that, be safe and be happy. Bye.